Welcome children. This is your Vanashree ma'am taking physics today. The topic is matter. This actually you have studied in chemistry also. You have studied in lower classes also. So let us revise fast. What is matter? Matter you already know is any substance which has volume and which has mass, and it is made up of tiny particles called atoms or molecules. Okay, so matter is any substance which has mass and occupies space. Occupies space means has volume, which has mass and volume. Okay, then you also know that matter is made up of small particles called molecules. Okay, and molecules in turn are made up of atoms. This is all your previous knowledge. You know all these facts. Okay. You also know that matter exists in three states. Exists in three states, and they are solid, liquid, and gaseous state. These are the three states that any matter exists. Now, these three states are because of different arrangement of molecules, different type of arrangement of molecules. Okay. Now, in solids, the molecules are tightly packed, are tightly packed without any space between the molecules. In liquids, the molecules are loosely packed, and in gases, the molecules are very loosely packed. Okay. Also, you must remember the space between the molecules is called intermolecular space. Right? You remember this term? Intermolecular space is nothing but the gap between the molecules or the space between the molecules. So, intermolecular space is maximum in gases because they are very loosely packed, moderate in liquids and minimum in solids. Okay, so now these are all your previous knowledge you have already studied in your earlier lower classes. Now we will learn about kinetic theory of matter. Kinetic theory of matter. This kinetic theory of matter explains the physical properties of matter in terms of the motion of its particles. Particles means the molecules. Okay. So the main aspects of kinetic theory are: first point, matter is composed of very tiny particles, that is molecules or atoms. Okay, then as I told you, the molecules are separated from each other by a space called intermolecular space. The molecules or particles in particles of matter are separated from each other by a space called intermolecular space. Intermolecular space or intermolecular space or interparticle space. Interparticle space. Okay, now so intermolecular space or interparticle space. Intermolecular space is what commonly used. Okay, now the particles or the molecules in the matter are not steady, but they are in constant random motion. Okay, so the molecules or particles of matter are in a state of random motion. Okay, they are always moving. Okay, and any moving object has kinetic energy, isn't it? So hence the particles or the molecules possess kinetic energy, isn't it? Any moving body has kinetic energy. Okay. Now the kinetic energy of these particles increases with increase in temperature, and vice versa, means decreases with decrease in temperature. So the kinetic energy of the particles increases with increase in temperature. And decreases with decrease in temperature. This means what? The particles are always in a random motion, right? Now, if you heat the substance, what happens is the particles start moving with more speed, with greater speed. That is why their kinetic energy increases. Kinetic energy depends upon the speed of the moving object. So, the kinetic energy of the particles increases when you heat the body. And if you cool it, if you freeze it, then the temperature of the body comes down and the kinetic energy of the molecules also reduces. That is, they start at moving at a lower speed or reduced speed. Now, there is always a force of attraction between the particles of the matter, and that is called intermolecular force of attraction or interparticle force of attraction. Okay? The particles always attract each other by a force of attraction. The particles hold each other. There is a force of attraction between the particles. Okay? The particles or molecules of matter attract each other by a force called intermolecular force, intermolecular force of attraction or interparticle force of attraction. Intermolecular force of attraction is more commonly used word. Okay? And the last postulate of kinetic theory, or the last point kinetic theory says, the constituent particles of the matter, particles or molecules of the matter are identical in all aspects. The constituent particles means the particles which make a particular matter. The constituent particles of matter are identical in all aspects. For example, water. Water is a matter. Okay. So water is made up of water molecules. All the water molecules are identical in all respects. That is the meaning. Okay. Now, this intermolecular force of attraction will be more in solids. Why? Because in solids the molecules are closely packed. So the force of attraction between them will be much stronger than that in liquids, because in liquids the molecules are little loosely packed. and in gases the molecules are very loosely packed. So the force of attraction between the molecules in the gases will be minimum, whereas the intermolecular force of attraction in solids will be maximum. So intermolecular space and intermolecular force of attraction. Intermolecular space is minimum in solids, but intermolecular force of attraction is maximum in solids. So you must remember this important point. Important point. Note: intermolecular space in solids is minimum. Why? Because the molecules are tightly packed. There is no space between the molecules. So intermolecular space in solids is minimum. This leads to intermolecular force of attraction being maximum. So intermolecular force of attraction in solids is maximum because the molecules are very closely packed. The force of attraction between them is also more. Okay. Next, intermolecular space in gases is maximum. So intermolecular force of attraction in gases will be minimum, isn't it? So intermolecular space in gases is maximum. So which leads to intermolecular force of attraction in gases becoming or being minimum. Why? Because there is lots of distance between the between the molecules of the gas. So the force of attraction between them decreases or becomes minimum. Okay. So now you already have seen this diagram, the arrangement of molecules in solids, liquids and gases. Okay. In solids, the molecules are tightly packed without any space in them. Okay. Okay, the molecules are tightly packed in solids. In liquids, they are comparatively loosely packed. Okay. So molecules are loosely packed. So the intermolecular space is more than that in solids. And in gases, the molecules are very loosely packed. Okay. So the intermolecular space is maximum in gases. Okay. This diagram shows the arrangement of molecules. This you must have seen in your previous classes also. In chemistry also you must have seen this matter. Chapter you must have studied in chemistry also. Arrangement of molecules in solids, liquids and gases. Okay. Now we will differentiate between solids, liquids and gases. Differences between solids, liquids and gases. Okay, this is the parameter or the property. Solids, liquids gases. Okay. Okay. So now the first parameter is molecular arrangement. Okay. So molecules are closely packed. Regularly and closely packed. Because they are closely packed, they are in rows, they are packed in rows and columns. So very regularly packed. So molecules are regularly and closely packed. In liquids, molecules are irregularly packed and loosely packed. Okay. Molecules are irregularly packed with space in between. Here they are closely packed in solids without any space. Without or minimum space between the molecules. In gases, the molecules are irregularly placed and very far apart. Irregularly placed and are very far apart. Okay, so that is regarding the arrangement of molecules. Okay, now the second parameter or second criteria is shape and volume. Shape and volume. Now solids have a definite shape and volume. Okay, so solids have definite shape and volume. Like for example, you take a sphere. It has a definite shape and it has volume also. Okay. Molecules are, liquids have no definite shape. For example, water, milk, it has no definite shape, but it has a definite volume. And liquids take the shape of the container. In whichever container you are placed, the liquid takes the shape of the container. Okay. So liquids do not have a definite shape, but they have a definite volume. But the liquids have definite volume, isn't it? 1 liter, half a liter, that is nothing but the volume of the liquid. Okay. So definite volume. And liquids do not have a shape and they take the shape of the container. If they are placed in a cylindrical container, the liquid will look cylindrical. If it is placed in a round container, the liquid will take the shape of, will look round. Okay. So liquids take the shape of the container. Okay. And the second, this same shape and volume, gases also have definite volume, but they do not have any definite shape. They also take the shape of the container. If a gas is filled in a cylindrical container, that gas takes the shape of the container. So gases do not have definite shape and definite volume also. Why? Because if a gas is filled in a big vessel, it will occupy the entire vessel. If it is compressed into a small vessel, it will take the volume of that smaller vessel. So they do not have definite shape or definite volume. Okay. So gases have no definite shape and no definite volume. Okay, children. Then the third parameter is interparticular force of attraction. Interparticle or molecule force of attraction. Now, intermolecular force of attraction is very strong in solids. Okay, intermolecular force of attraction is very strong in solids. Okay. In liquids, also intermolecular force of attraction is there, but less than or weaker than solid. Okay, intermolecular force of attraction in liquids is less than or weaker than that in solids. And in gases, the intermolecular force of attraction is weaker than that in liquids and solids. Okay, intermolecular force of attraction in gases is weaker than that in solids and liquids. Okay. The next parameter is compressibility. Compressibility means putting pressure and compressing the substance. Compressibility. Okay. Solids cannot be compressed. It will break, isn't it? Solids cannot be. However much you press a stone, it will not become small. It will not get pressed. Solids cannot be compressed. Liquids also cannot be compressed. Liquids also cannot be compressed. Gases can be very easily compressed. Gases can be easily compressed. Okay, that is regarding compressibility. Fluidity, that is flowing, nature of flowing. So solids cannot flow, liquids can flow, gases also can flow. Okay, fluidity. Solids cannot flow, liquids can flow on slope but cannot leave the surface, isn't it? But cannot whereas gases can flow in any direction. Okay, then expansion on heating. When you heat any substance, it expands, isn't it? So when you heat Solids expand little, liquids expand more than solids, and gases expand more, maximum, than solids as well as than liquids. Okay. Expansion on heating. Solids expand little on heating. Okay. Liquids expand more than solids on heating. Liquids expand more than solids on heating. Gases expand more than liquids and solids on heating. Okay. And the last point of difference is movement of molecules. Movement of molecules. In solids, the particles only vibrate. Vibrate means to and fro, they keep moving, staying in the same position. Okay. Molecules have vibratory motion. Okay. Liquids, the molecules move in all directions except in the upward direction from the liquid surface. Molecules in liquids move in all directions except in the upward direction. That means what? From the surface of the liquid, it cannot move out. It cannot move in the upward direction except in the upward direction from the liquid surface. And gases can, molecules of gases can move in all directions.